October 10th, 2016. Guys, you're looking at images that are just over 4 months old. They were taken in June 2016 of what the ancients called Nibiru. You're looking at 3 of the orbital planets, or planetary moons, or planetoids. Here, if we back out, you'll get 4, and they're going to show an animation of events. Again, Juno spacecraft after it went through the asteroid belt. You can see one in the top right. We'll go into an animation. They're paying very close attention to this, and they're glad that people that don't understand mythology and the way that this breaks down, they're glad that people are not watching Jupiter, which this is, and these are 4 of its major moons, which is only 4 out of over 60 of the moons. And the size that we're dealing with here, guys, is kind of beyond scale. Jupiter itself, called Nibiru by the ancient Anunnaki, the Phoenicians, the Greeks, the Romans, all of this ties together, just the way one thing is handed down from generation to generation and from empire to empire. But guys, we're going to go into that, but I want you to pay attention to what we're looking at and why I'm saying this. As long as they've got people thinking about something coming in from a faraway galaxy, they're not going to see what's right under their noses. And we've got some strange orbits going on here. First, you're looking at the 4 Galilean moons discovered by Galileo, because you couldn't see the other smaller ones at that time. Europa, Ganymede, Callisto, and Io. Europa is ice planet, guys. They're really checking this thing out because it's got water and ice on it. But these physical orbital characteristics of the moons vary widely. These 4 Galileans are all over 3,100 kilometers or 1,900 miles. The largest, Ganymede, the second one, is the 9th largest object in our solar system after the sun and the 7 planets, Ganymede being larger than Mercury. Think about that. The other Jovian moons are less than 250 kilometers. Think about that, 160 miles wide. Now, picture something just on the other side of the asteroid belt, spinning with over 60 moons. Look at this object from the ancient Sumerians. It's a star or planet, but many people call Jupiter a gas giant. And what that image shows is a 6-pointed star. We'll get into that, but there's 67 known moons of Jupiter. This gives Jupiter the largest number of moons with reasonably stable orbits of any planet in the solar system. The most massive of the moons are the 4 Galilean moons that we just looked at. Then you go into the 19th century when you got your telescopes were getting bigger and better. Dozens of smaller Jovian moons have been discovered and have received the names of lovers of conquest, daughters of the Roman god Jupiter, of its Greek equivalent Zeus. The Galilean moons are by far the largest and most massive objects to orbit Jupiter, with the remaining 63 moons in its rings together comprising just 0.003% of the total orbiting mass. They look like asteroids. It looks like that as its orbit, which we talked about, comes closer to the sun and it gets further away, and it's the only planet that does not have its orbital center within the sun itself. But the Sumerians had called Jupiter Nibiru, and also Mulababa, which means bright sun-like star. Nibiru simply means ferry, ferryman, or ford. Micus Nibiru is the toll one has to pay for crossing the river. And there will be a toll to pay if this thing crosses the asteroid belt. And is another title for Jupiter as it changes position and crosses the sky. It's a very unusual orbit. The Star of Babylon and Marduk frequently spoke of the inscriptions, it is Jupiter. The Babylonians had used a 12-year orbit of Jupiter along the ecliptic to define the constellations of the zodiac. It's actually about 11.82 years, I think, as far as orbital time. And this planet has also represented the god Marduk. We talked about this before. Marduk is the chief god to emerge in Babylon, which has defeated Tiamat, the serpent of chaos. You can go through and read this. I've got videos about it. But here, this 6-sided star on these ancient Sumerian tablets, you see the orbital moons around it and other planets, And as this spins and gets closer and closer to the asteroid belt, what happens? But it matches the second pinnacle of Jupiter in Hebrew. The first pinnacle had 9 points, but the second pinnacle, if you go back and look at it, matches this perfect. And it means Jupiter. That's what you're seeing in the top left of this ancient Sumerian tablet. Went back, and the Phoenicians understood this. Everyone called this Jupiter, and it could come in close enough, and it has in the past, to not only disturb the asteroid belt, but send them cascading into the inner solar system. These are some of the other planets, moons. And a lot of them are elongated. They look like asteroids in the close-up images that Juno is sending back now. Think about this now. We're getting into some orbital mechanics. 1 AU is the distance from the Earth to the Sun. 3.2 AUs is the average distance of the asteroid belt from the Sun. But it's almost 1 AU wide. And you're talking about an AU being 99 million miles, roughly. And you say, well, Jupiter and its moons are much further than that. Well, not really. Let's take a look at some of the things here. First of all, you've got Ceres, Vesta, Pallas, and Hygeia are the largest asteroids that we know about. But there are over 200 that are over 100,000 meters in diameter, and 0.7 to 1.7 million asteroids with a diameter of 1,000 meters or more. Look at this, guys. This will explain it very clearly. Jupiter. Then you've got Mars, then Earth. So you've got to realize where we're at as far as the asteroid belt, where Mars is at, and that the closest that the planets get, Jupiter to Earth, they're saying is 365 million miles. But it almost doubles that because of this unusual wobble. In other words, Jupiter's gets almost, goes from 365 million to 601 million miles. And remember, that's not just an ellipsoid orbit. The Sun and the Jupiter have a very strange orbital relationship because the center of gravity of Jupiter is not within the Sun. It's the only planet in the solar system, but many don't consider it a planet. They consider it a fell star. Look at your Trojans. These are not within the white band that it is the asteroids. That's, you're going from 3.2 to about 3.6 difference, not very much between Jupiter's closest approach to the Sun and to Earth and where it gets to the asteroid belt. Plus, look at the Trojans in the green, guys, and the Hildas in the brown. Jupiter crosses those anyway. Then it scatters them with its 64 plus or 67 plus moons. But located between Mars and Jupiter, the belt ranges in distance between 2.2 and 3.2 astronomical units, nearly 1 AU wide, 99 million miles. 329 million to 478 million kilometers. It's 1 AU thick. That's the distance between the Earth and the Sun. Now, Saturn, look at these little charts. You've got Saturn is 88.2 million miles from the Sun. The Earth is 92.96. That's 1 AU. Mars is 141.6 million miles, or about 1.5, not quite 1.5 AU. So let's look at this. The distance between the Earth and Jupiter at its closest point is 3.9 AU. It's the asteroid belt gets within 3.2 AU. So now in part 2 of this video will be the timing of when Jupiter will be the closest to the Sun and the closest to the Earth, and the Earth will be where you see this blue dot, not over in the chart, or slightly behind that, because what you would be trying to determine, and NASA may well know this with the asteroid missions and the things like that we're seeing. They may well know, have already went through with the supercomputers and done what needs to be done and shown to the public. But showing the orbital patterns, the timing of the possible collisions, and the closest approach of Jupiter to the asteroid belt itself, then to Earth and to the Sun. But look at the size of some of these asteroids within the asteroid belt compared to Earth. Think about that. Pretty impressive size, and you get those kicking around like pool balls on at the break of a pool tournament or a pool game, guys. Nothing pretty can happen from it. Now, if you want to see what the ancients call Nibiru, and you want to know the truth about it, we're going to have part 3 of this. But tonight, 90 minutes before sunrise, looking east, you'll see Arcturus, Jupiter rising in the angle with the moon rise. And you can see all through October the different locations. But remember, the reason I say it's important is because if we're not paying close attention to what's very close to our planet, what has been called Nibiru in the past, and study it for ourselves, because we don't get that much information. August 12, 2016. Guys, you're looking at a graphic of the solar system starting with Saturn in the right corner. It appears larger than Jupiter there in the bottom, but that's only because of the proximity of the artist as he's looking toward the inner solar system. Notice some of the moons there to the right of Jupiter, and that has everything to do with part 3 of this series, and it's not the last part. But what you see from Jupiter inward is the asteroid belt. Then you see Mars, the Earth, Mercury, Venus, and you see the moon around our planet, again, Earth there, and the sun in the center. Now, you've got the moons rotating around Jupiter, and you're going to have to crunch the numbers. That's going to be in part 4, but I'm going to give you some good ideas here. Now, in this graph, you can see it's exaggerated as far as the size of the planets. But again, Jupiter with its planets, asteroid belt, Mars, Earth and the moon, Venus and Mercury and the sun. Now, what would it take for Jupiter to move closer to the Earth? And it actually does by about 300 million miles at its closest point in its rotation. But check out this graphic. To the left, the orange line is the size of the sun. These are actual scale. Then Mercury, Venus, Earth, and the moon, Mars, asteroids. Then the 4 moons of Jupiter where it says Jupiter, but the large brown circle, guys, is Jupiter. Then Saturn, Uranus, Neptune, and then the moons of each one. And notice how even Uranus and Neptune are so much larger than the Earth. Here's scale of Jupiter and the Earth. We'll take 1,300 of our planets to fit inside of it, but it's just on the other side of the asteroid belt from Mars, and it's the largest object in the solar system other than the sun. Now notice your timestamp, which is yesterday as I was starting to put some of this together, October the 11th, and this is the actual location of the planets at that time. The Earth, Ceres, Mars is on one side of the planet. Now, Ceres represents one of the largest objects in the asteroid belt, and it represents the orbital path of the asteroid belt, except you're dealing with millions of objects. That's almost 99 million miles wide, 1 AU. Now, here's a couple of dates. October 26, 2017, Jupiter will be at the solar conjunction. 214, May 9th, Jupiter opposition, Jupiter solar conjunction. Those are the dates that give you as far as the important dates. But I want to look at some of the other dates here. Again, October 11th, yesterday, timestamp. And on this solar system scope model, you can just grab any planet, start rotating it. Notice your time stamp at the bottom. Earth and Venus is just lined up. Venus and Mercury are lined up right here. As I back this up, let's come back forward. Notice Jupiter, the Earth, Venus, and Mercury are within the magnetic field of the width of Jupiter, because it has a magnetic field 18,000 times larger than the Earth's magnetic field. Now check this out. April 10th next year. So you've got April is the 4th month. We're into the 10th month, so we're about 6 months exactly. And we've got an alignment between Jupiter, the Earth, Venus, and Mercury. To me, this is much more important than the conjunction date. And everything has to do with the magnetic fields, guys. And this is going to get deeper as we go into the couple more parts. They're almost ready, just finishing touches. But Jupiter's magnetic field goes out about 4.3 million miles. That's in front of Jupiter. If we come around, notice Mars is going to line up on February, March the 2nd, March 2nd, 2018. Now, Mars is closer as far as any effect as far as the asteroid field, because the asteroid field lies between Jupiter and Mars. But about 4.3 million miles out in front of Jupiter is the outer extent of its magnetic field. But guys, the blowback, just like the Earth has a magnetic field, and then it has the bow shock, and then you have the magneto tail that extends for millions of miles behind it on the opposite side of the sun as it faces the solar stream. Well, Jupiter's solar stream goes back to the orbit of Saturn, about 4.3 AU. Now, that's 4.3 times the distance of the Earth to the sun. That's further than the closest approach of Jupiter and the Earth. Jupiter and the Earth, at its closest approach, is about 3.8 AU. The final touches on this, if you haven't already started to see what's going on, will be in the details of part 4. But here we're dealing with Juno. We're dealing with 4 months ago. And Juno is the satellite that we've sent up to study not only Saturn and its moons, but what is a very key part of the end of this, which is a moon of Titan and Saturn. But Jupiter is known as Nibiru in the ancient text. I showed you that before. But guys, pay attention to this, what they're talking about with Jupiter. It says, one of the brightest objects in the night sky, Jupiter has enthralled humans since ancient times. Today, scientists believe that learning more about the planet may be the key to discovering our solar system's origins and formations. They theorize, and they know, that Jupiter didn't always rest where it is now, but that it moved throughout the solar system in its youth, disrupting the formation of Mars, influencing the formation and location of the asteroid belt, and more. Just like I've been telling you. Notice the date, August 5th, 2016. Juno came through there getting these pictures on July 4th. There's in the next part of this series, we got recorded the Juno satellite as it hit the front bow shock. But guys, the whole thing about this is the magnetosphere of the Earth, the magnetosphere of Jupiter. And did you know that Ganymede, the largest planet, is the only moon, supposed moon in the solar system that has its own magnetic field? And it's larger than Venus. Think about that. That magnetic field can be disrupted. Ganymede could crash into the magnetosphere, into the asteroid belt, just like it possibly has done before. What would it take? A magnetopause reversal? In the next part of this, guys, I'm going to show you 2 magnetopause reversals that could affect the entire inner solar system, and you've seen them on my channel. And I'm going to tie that into how Ganymede could be released, as well as some of the other moons, because 4 of the Galilean moons are planetoid objects that are very large. Guys, why are they spending billions watching this? You saw where NASA said that they think Jupiter has done this before, disrupted the inner solar system, just like the ancients said that Nibiru did. And you've seen where you can trace it back through the Phoenician languages, through the Sumerians, that they call Jupiter Nibiru. Guys, it's so huge. 130 of our planets could fit into it. And this is just an animation of its moon Ganymede that's larger than Venus. This is what they were picking up as far as its magnetopause and the auroras around it. Look at that. It has a magneto field, and it has auroras, and so does Jupiter. These are massive. Don't stand a chance. They have magnetic fields. I think that's got a lot of them upset. But these are high-definition images of the solar wind coming from the sun, which is blacked out in the right, so that you have this high-definition image. Imagine the strength that you're seeing. This video has everything to do with that, because when these solar winds pass our planet, in each of the planets, it creates the magnetic field. Now, this pink area called the bow shock is how far the sun's solar winds reach out. You notice all the planets are there. Jupiter, Saturn, Neptune, Pluto, all the way down. You've got terminal shock, the heliopause. This image, infrared of our sun, double red wings, infrared imaging. This is the layout of Jupiter's magnetopause, the magnetotail, which goes all the way back 403 million miles to the orbit of Saturn. Think about that, 7 million out front, but because of the solar wind, it goes back that far. Now, what happens if the solar wind of Jupiter reverses? Remember, it is the second largest object in the solar system. Its magnetic field is 18,000 times larger than our planet. What happens if something causes this giant magnetic field to reverse? Would we see it on the inner planets? Could that be possible? It is possible, and we've seen it before. Could it become so strong as the second largest object in the solar system, as its magnetic field increased as we were going through a solar minimum? Could that happen? This animation with real images of Jupiter in the center and its moons, remember it has 67 total known objects orbiting it. What would happen to that with a prolonged change of solar wind direction? Could an event happen to where there's Jupiter there, next to inline is the asteroid belt? That's what we've been talking about. You've got 60-something objects orbiting around Jupiter. This is a graphic, but it shows the sun and it shows the Earth. The magnetic lines that connect both of them are connecting every planet in the solar system, in our solar system. They're not straight lines, and that's important to understand. We'll point that out a little further. Let's go back a few months to April of this year, April 22nd, 2016. I put the red dot over here just to simplify it, because the solar wind is coming from that direction. You see the arrows? The Earth is the black dot, guys. A lot of you have seen this before, but just if you haven't, this has happened twice, back in 2012. It happened this April 23rd of this year. Let's take a look at anyway, we got solar stream, just like you were seeing in the first of this video, those golden waves of energy. They're coming from the sun with the arrows. Now, as we get into the April the 23rd, something happens. This went down for 4 days because of it. The solar stream reversed. Check this out. We were watching it recorded. I've got a couple of videos of it. It's called the magnetopause reversal. I think if you type that in, you can find the full videos. But that happened. What caused solar wind of this to overcome the solar stream from the sun? What was behind our planet? It was the worst collapse of the magnetopause I've ever seen, and all the energy was trapped inside that. Let's look at the planets on that day. Jupiter, the Earth and Mars and Saturn are on the bottom side of the sun. You see Venus at the top. You also have Mercury there. But the straight lines of magnetic connectivity, and each planet has them, you've seen it before, are not straight. Look at today's magnetopause model. See how each line is curved? The red dot is Mars, the yellow dot is Earth. And these interplanetary magnetic field lines, or IMF lines, are not straight. So when you look at the image to the right as it's overlaid, as the Earth is to the right of Jupiter, the magnetic field lines from the sun and cross the Earth going towards Jupiter on that day, on the exact day of something that is unheard of, except one other time that I know of in the history of where we could record it with instruments. I'm sure it's happened before, and I think it happened for more than a few days about 12,000 years ago. We'll get into that. But here you've got Jupiter. You see Io, Europa, Ganymede. Ganymede has its own magnetic field. It's the only planetoid or moon in the entire solar system that also has a magnetic field. the way that Jupiter does. Now, Jupiter has its auroras, telling you that it has a magnetic field, and these auroras are controlled by these moons, they say, if you study about it. It also has rings, but it's a finer dust particles than Saturn, but it's from the many collisions, and like I said, we've got over 60 known moons, but there's millions of these tiny, small pieces, and it's the indicator of the destroyer and what has happened before. This is its magnetosphere, or the shields of its planet. Just the same way the Earth has them, it has them, and it reaches out. And it's just like the sun. It is. Some people will call it a pulsar, not just a failed star, but a pulsar. Now it has its own radiation field, as you can see in these graphics. But with any disruption that would cause the magnetic reversal between Jupiter or any planet, Saturn, with some of these giants behind our Earth, you could, through any of this dust particles, any of these 66 moons, into the asteroid belt, you would see why NASA now theorizes that Jupiter has done this before. It created the moon, it created the asteroid belt. That's why the ancients called Jupiter Nibiru. Look through the other videos. Look at the timestamp here. We're going to see, as we get into next year, we're going back into March again, you're going to see Venus, the Earth, Mercury, and Jupiter line up again. It will be interesting at that point to watch the magnetopoles. It'd be very interesting indeed to see what happens at that point. That's April 10th, 2017. Now, I'm not saying any days because it would take days for this to line up. Not a date setter because God says no one knows that day. But guys, 12,000 years ago, and I think I can prove it, something happened very similar to what we're talking about. And I think that was the last written legend that we know of about what was called Nibiru. Very important. 12,000 years ago is when I also think that the flood of Noah happened. The reason I say that is because, guys, you had the first 6 days, you had the day of rest. But if you read the Bible, one day with man is 1,000 years with our Lord. And that would make very logical sense that it took 1,000 years per phase of what we went through in Genesis. You understand what I'm saying? And then we've had another 6,000 years or so since that point. And 12,000 years ago, something happened on this planet that's very well documented. I've documented it in videos before. I'll briefly touch on it here. But notice at the very bottom line of this, and you can read it, it says strong currents in the magnetosphere generate permanent aurora around the planet's poles and intense variable radio emissions. They were picking these up even in 1950. But they say that, which means that Jupiter can be thought of as a very weak radio pulsar. Think about that. It's the electromagnetic spectrum has been seen in the infrared, visible, ultraviolet, and soft X-rays, and it's like wings going out both sides of it, just like a couple of the images that I was showing you. Guys, there's important information about this, and again, I know a lot of people, it's just so far-fetched that it's not quite grasping it, and some people are just afraid of it because it blows their solar flare cell phone camera theory away. But this is Jupiter. This is graphics of what the magnetic field would look like, very similar to our planet. Now, it varies a little differently because of the way the moons are. It has many more moons. We have one, and it has many more. This is Callisto, on the one of the larger moons, the 9th largest object in the solar system. It has its own magnetic field. To me, because of that magnetic field interacting with the magnetic field of Jupiter, that would be the main pinball if you had something change. And you just saw evidence of that magnetosphere change. It wasn't just one model. The Japanese models picked that up too.
But now the scientists are looking deeper. They're creating models that can go back forward in time for thousands of years. and predict exactly where the planet should be on the normal basis, and they can go back thousands of years on these supercomputers. So they've entered all the information of the solar system that they have. They've input every critical piece of information they could. Let me read this. I'm going to link to the article. It's called Jupiter, the Destroyer. The scientists that are doing the models say we should be thankful that the early solar system was not conducive for life. During those early days, Jupiter was less constrained by its current orbit and swung through the early solar system, annihilating a first generation of inner planets, as reported by new evidence in the proceedings of the National Academy of Sciences. Based on a simulation of early planetary formation, the destructive behavior of an adolescent Jupiter may explain why our solar system has so little in common with other planetary systems. In these other systems, large rocky planets orbit extremely close to their host star, much closer than the distance between Mercury and the Sun. Jupiter's wanderings is a possible reason to our solar system's lack of inner rocky planets. Now remember, this is the National Academy of Sciences. It says, after the planetary apocalypse, their words, Jupiter eventually settled into its current orbit, while much of the other debris of the first generation planets plunged into the Sun. The remnants that did not suffer a fiery fate would eventually coalesce into the modern inner planets Mercury, Venus, Earth, and Mars. Another reminder that we are nothing more than recycled remains of a planetary apocalypse. Now, guys, don't let this confuse you when they say, well, so God didn't create it. I saw a lot of comments about, well, so God didn't create the Earth, it was Jupiter. God creates everything. How does he do it? Natural. It's called supernatural. Super means more natural. It's not some mystical thing. He controls everything. And when we see the events that are coming down in Revelation, you'll understand exactly what I'm talking about. He told Job, you don't know what I have in store for that great day, on the day of the Lord, in that day of battle. What treasures are in heaven? What the hailstorm? Think about it. But I wanted to read this. I'm going to link to the information. Also, ScienceMag.com has reported on this back in 2015. It goes through basically the same information, talking about how Jupiter retreated from its closest approach to the Sun about the distance of Mars' orbit today. What's between Mars and Jupiter now? The asteroid belt. It left behind the most rocky remnants that later coalesced into our solar system's inner planets, including Earth. And think about this, the ancient Nibiru legends of Tiamat. And you see how Jupiter has bounced in and out, as well as Saturn. We're seeing the Sun going to a solar minimum. Just about a month ago or less, we saw the magnetopoles reverse for 3 days, with the Sun decreasing in energy. We're looking at increased radiation, gamma rays from outside our solar system coming in. Doesn't have to be from Jupiter or Saturn, but that would affect the gravity, the orbits of every planet in that path, guys. We're not going to be told about the variances and the difference that they see. You'll have to check it out yourself. Many people have noticed the differences. But again, as Jupiter retreated from its closest approach to the Sun, the distance of Mars today, it left behind the most rocky remnants that later coalesced into our solar system's inner planets. The information's out there. And guys, let me say this. When someone's telling you that you can see with your cell phone the second sun, but you can't see it with your eyes, then back off. Realize right away there's something wrong with that. First of all, if there was a second sun visible, you're not supposed to look at the sun anyway.
but you would be able to see it with your eyes. It wouldn't be on a 10-cent camera in a cell phone.